Okay, so due to popular demand, people wanted to see a video with a bunch of examples done. And so I'm going to go through a whole bunch of different questions that you might be asked about polynomials for the quiz tomorrow. So let's go ahead and dive right in. Okay, so here's a common question, or a question that a lot of folks had questions about. Which was, so say you've got a polynomial and there's some constant, some unknown in it. In this case, it's c is our unknown, and it's right here, multiplying the term with x. And you want to figure out what that number should be so that -1 is a 0 of the polynomial. And this -1 is arbitrary. It could be any number. I could have asked you to find c so that -2 or 2 or 5 was a 0. So it really gets at the heart of what does it mean for something to be a 0. To be a 0, that means that when you plug it in, you get 0 out. So this is telling us -1 is a 0 of the polynomial, tells us that p of -1 is 0. You plug it in, you get 0 out. And so if you wanted to figure out what c needs to be, which is right here in our expression, everything else we found numbers for. We just evaluate p at -1 and set it to 0, and we're just going to figure out what c is. So let's go ahead and do that. So we plug -1 in, and that's going to get us 3 times -1 to the 7th plus -1 to the 5th minus 3 times -1 cubed, and then c plus c times -1 plus 5, and the result has to be 0 because we said that -1 is a 0. We want -1 to be a 0. Okay, so let's go ahead and evaluate all these. Now I just want to recall to point this out to you that -1 to an odd power is equal to -1. Because you multiply -1 times itself 3 times, negative, 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 you get a negative answer. 1 times 1 times 1 is 1, so you get -1 when you raise it to the 3rd power. That's true if you raise it to the 5th, or the 7th, or the 9th, and so forth. And then -1 to the even power, any even power, is going to equal +1. The reason for that is because every pair of negatives you'll cancel out, because negative times a negative is a positive. So -1 to the 2nd power is going to get you 1. -1 to the 4th power is going to get you 1 again. -1 to the 6th, to the 8th, and so forth. So an odd exponent for -1 is -1. An even exponent for -1 is +1. Okay, so these are all odd exponents if we take a look. So this is going to give us -1 here. So we're going to have -1 for this, -1 for that, -1 for this, -1 for that. So let's go ahead and plug all those in. So we get -3 minus 1 plus 3 minus c plus 5 equals 0. So 3 times -1 to the 7th is -3, plus -1 to the 5th, that's -1, minus 3 to the times -1 cubed is +3, because you have a -1 times -3, so it's positive. And then -1 times c is minus c plus 5 equals 0. So let's simplify this all out. We get those cancel, -1, so we have -1 minus c plus 5 equals 0. And so that tells us that -c plus 4 equals 0, and so c equals 4 in this case. Okay, so that's how you can solve that problem. Okay, here's another problem. So suppose we've got a polynomial whose graph is given to us over there on the right. Assuming that it has no more zeros than the ones that are shown, we're going to answer these 3 questions. What's the minimum degree? What's the minimum value of p? And then what's the end behavior? So these are 2 different questions, A and B, and they're getting at 2 completely different things. So minimum degree is what's the fewest number of roots this thing has, or what's the really what's its power going to be? What could it be? And if we count, it crosses here here, and then it looks like it crosses twice right there. And so if we count the number of crossings there are, then you know there's at least 4 factors, right? So this is 4 factors. I haven't answered the question yet, but I have basically, because if there's 4 factors, you know that's going to look something like x minus, you know, whatever that number is, like 2, and x minus 1.8, and each of these each of these factors is going to give us another power. And since there's 4 of them, we're going to have x times x times x times x, which is going to give us a 4th degree polynomial. So it's at least 4th degree. Could be more, but that's the minimum degree. Okay? So the minimum degree is a 4th degree polynomial. Minimum value, totally different question, even though they both contain the word minimum. Minimum value is saying, what's the smallest y value this polynomial is going to hit? And if we look at the graph, we can see that it does have a minimum. As I'm coming in from the left, it's going to bump down to this lowest point right here. So there's our minimum point. Our minimum value is down there. And then it goes back up, and it's always above that point. So this is kind of getting at the range question. What is the range of the polynomial? What's the minimum? And if you look at it, it's a little bit below -4. It's probably, if I estimate over here on the graph, I can kind of draw a line. That looks like it's about -4.2 or something. So we'll say -4.2. It's a little bit below -4. End behavior. Okay, last question. So for end behavior, we note that as we go left, so if I'm on this function, if I'm writing it like a roller coaster, as I go left, it goes up. As I go right, it goes up. Assuming that it has no more zeros, that means it doesn't do something like that or like that. Then we're going to go left and up, right and up, and so our end behavior would be as x approaches -infinity, as we go left, the p of x polynomial approaches +infinity. And similarly, as x approaches +infinity, so this is left, this is right, p of x approaches +infinity. Both of these are up and up, left and up, so left and up, right and up. That's our polynomial there. And that should match up with our degree answer, right? We said it was a 4th degree is even degree polynomial. Both of the ends have to go the same way. Odd degree polynomial, they're opposite. Okay, here's another question. Factor the polynomial and determine the roots. So let's go ahead and factor this one out. I'm going to always do greatest common factor first. So we're going to do 4x is the greatest common factor. I am left with 1 plus 8x cubed. The 4 divides both 4 and 32. I see an x in both places. The highest power of x that's common is x to the 1. And so I'll pull out 4x as the GCF. GCF. F over here. Not E. Okay. Now we note that it's a sum of perfect cubes. This can factor further. So the sum of perfect cubes factors like 1 plus 2x, 1 minus 2x, plus 4x squared. So 4x. So 8x cubed, I can rewrite this. So this is my answer. This, I factored it. So this is the factored out polynomial. And the roots I could read from that, x equals -1/2 and 0 would be my roots. But just to reemphasize how 1 plus 8x cubes factors into the 1 plus 2x times 1 minus 2x plus 4x squared, so this part where this comes from, that's the fact that 1 plus 8x cubed is equal to 1 cubed plus 2x cubed, right? So it's a sum of 2 cubes. And the formula for a sum of cubes is a cubed plus b cubed equals a plus b, followed by a squared minus ab plus b squared. And so I know what a and b are. This is a, this is b. 1 is a, 2x is b. So we plug each of those in for a and b. So 1, maybe I'll highlight this with colors. 1 is a, and 2x is b. Okay. Blue. Okay, and so we're going to get 1 plus 2x, 1 plus 2x, a plus b, and we have a squared, 1 squared is 1. We have minus ab, so minus 2x times 1, it's minus 2x. So there's a hidden 1 there, but we don't write it because 1 times anything is that number. And then the last part is the 2x squared. And 2x squared is 4x squared. That sounds wrong. 2x squared with parentheses is 4x squared. Because remember, a is 2x. It's not just the x part. Okay. So that's how that problem factors out. Okay. So here's another example where we're going to factor a polynomial and determine the roots from it. Just be mindful with this kind of polynomial that this actually factors just like a quadratic factors, because if we were to square the middle term, we get the leading term, the first term, x to the fourth. And so let's go ahead and factor it like we would a quadratic. We're going to have x squared and x squared instead of x and x though. And we need the numbers to multiply to negative 2 and add to 1. So that's going to be plus 2 and minus 1. And now we're going to factor each of these quadratics further. Before I do that, though, I'm going to just redistribute to make sure that we actually get what we started with. So the x squareds and x squareds, if we were to FOIL that, so I'll just do that in the upper right. So if we were to multiply x squared plus 2 by x squared minus 1, then I'm going to get x to the fourth. That's from x squared and x squared and minus 1, that's going to give me minus x squared, 2x squared, that's plus 2x squared, and 2 times negative 1, that's going to get me minus 2. And so we see, in fact, we do get what we started with, x to the fourth plus x squared minus 2, if I were to distribute it back. So now let's go ahead and factor both of these further if we can. So this one's done. We can't factor x squared plus 2, but this one is a difference of perfect squares, so we're going to get x squared plus 2, x plus 1, x minus 1, and so our roots are going to be negative 1 or 1, and those come from the two linear factors. X squared plus 2 can't get factored any further because there's no real roots for that. Okay, so that would be factoring that fourth degree polynomial that looks like a quadratic. Okay, another example. Let's factor this polynomial and determine the roots. Lots of factoring ones. So this looks like a grouping problem because we see there's 4 terms, and so I'm going to go ahead and try to group it. And first, though, I'm going to factor out the greatest common factor, so we're going to pull out a factor of negative 2. And in general, if your leading term is negative, I always factor negative sign out because I find it easier to think what will happen if the leading term is positive instead of negative. So we're going to pull negative 2 out from everything, and that's going to give us x cubed minus 3x squared plus x minus 3. And now we group the middle, the first 2 terms and the last 2 terms, so let's go ahead and do that. We have minus 2 stays in front, and then I'm going to group x cubed minus 3x squared, those terms, plus, and these last 2, x minus 3, and then factor each of these by grouping, right? So greatest common factor of the first one, that's going to be x squared. So we have x squared, and then we've got x minus 3 left, plus x minus 3. Now there's no greatest common factor for that, so we don't have anything to factor out. Okay, so what's common here? Well, we have x minus 3 and x minus 3, so we're going to pull that x minus 3 out. That gives us negative 2, x minus 3, and then x squared plus 1. And if we were to kind of redistribute this x minus 3, I'll underline it. If we were to redistribute this x minus 3 back to each of these, you know, x squared and 1, we'd go back one step. We'd go back to where we started. X squared times x minus 3 is the first term, first bit, right? This is x squared times x minus 3, and then we have 1 times x minus 3, that's the second bit. Okay? So let's, I'm going to go ahead and erase these guys. Okay. So now that we're here, we've fully factored it, because x squared plus 1 does not factor any further, unless you use complex numbers, and we're not doing that. So we can determine the roots from this. We can see that x equals 3 is the only root. And this is the fully factored polynomial. Okay. Now we're going to write the equation of a polynomial with some conditions. So we're kind of done with the factoring practice. Now we're going to do some write the equation of a polynomial with some conditions like degree 4 and zeros at 0, negative 1, and 2. So we're going to just start building it up and see if it's satisfying each of these conditions. So first off, we know zeros. That's going to give us, you know, x plus 1, x minus 2. And so if I were to stop here, I'd say, okay, does this satisfy all my conditions? Well, I've got this stuff. Check, right? That's done. We've got zeros at 0, negative 1, and 2. But the degree is not 4. My degree is currently 3. And so that's not right yet. So what could I do? How can I pump this degree up 1? Because the degree is 3 right now, and I need to get it to 4. Well, you might say, let's try multiplying by, I don't know, x minus 1, for example. If I tried to add another factor, then we'd see we're at degree 4. So now degree 4, check. But we wouldn't have zeros only at 0, negative 1, and 2. So now that condition's not satisfied because I'd have an extra 0, because this would give me x equals 1 would be a 0. And so I can't multiply it by a linear factor. Right. So how do I get this degree to go up? Well, you might think, could I just like square one of these guys? Maybe like x squared plus 1. That would be degree 4, good. But then we'd have actually gotten rid of this 0, because x squared plus 1 is never 0. And so we'd have 2 zeros and not the 3 zeros required. So I can't do that either. Okay, so we can't multiply it by a linear factor. I can't just square one of the x's on the inside. So what could I do? Well, I could square any one of these factors. So if I squared x, that's going to get me x squared times x plus 1 times x minus 2. We've got 3 zeros, 1 at 0, 1 at negative 1. So we have 0, negative 1, and 2, right? 0, negative 1, and 2. And my degree is 4 because we have x squared. So this is a degree 2, this is a degree 1, this is a degree 1, so we get a degree 4 polynomial. So this would work. Okay? And I could have squared any one of these factors. I could have put the 2 with the x plus 1 factor, I could have put the squared with x minus 2 factor, so forth, and that would have satisfied it. Okay, let's do another one like that. Write the equation of a polynomial with degree 3 and zeros only at 0, negative 1, and 3, such that p of 2 equals 13. So let's go ahead and start building it up. We have a degree 3 polynomial with those zeros. So it looks like all the zeros are accounted for, so let's go ahead and write it out. We know p of x is going to look like x times x plus 1 times x minus 3. And let's go ahead and plug, and And so what can we do with this polynomial? We're forced into this, these three factors because our degree is 3. We've got that, and we've got that accounted for, but we haven't yet taken into account the p of 2 equals 13 yet. And if I were to add a constant, k, onto this, that's supposed to be a plus, then I'd actually change these, and I'd no longer satisfy this requirement. Because if I plugged 0 in, and then I would get k out as my answer. And so then 0 isn't a 0. Likewise, if I plug -1, I get k as an answer. If I plug 3 in, I get k as an answer. So I can't just add a constant onto the end. So what I have to do is multiply by a constant. So we'll put a k in front, and then figure out what's k need to be so that if I plug 2 in, I get 13. So let's go ahead and do that. We know p of 2 is equal to 13 based off of this requirement. Go ahead and erase that. So we know p of 2 is 13, and I also know that it's equal to k times 2 times 2 plus 1 times 2 minus 3. So let's go ahead and figure out what this number is over here. We have k times, it's a k times 2 times 3. 2 minus 3 is -1. So it looks like our number is -6. 13. 13 equals k times -6. And so that tells us then that k equals -13 over 6. So our polynomial would look like p of x, I'm out of room, I'll just use another color. So p of x would be -13 over 6. Missing my first x times x plus 1 times x minus 3. At this stage, you might double check that everything works as you expect it to. Namely, is it a degree 3 polynomial? Well, we have 3 terms of x, 3 linear factors with x, so yes, it is. Do we have zeros at 0, -1, and 3? The answer is yes, because 0 times anything gets you 0. -1 times anything gets you, -1 plus 1, that's 0, times anything gets you 0, and then 3, you plug that in, then this one's 0, and so you get 0 as a result. So we've got these 3 conditions, and then the last one, if we plug 2 in, is that 13? Well, let's just double check to see if that's true. So -13 over 6 times 2 times 2 plus 1 times 2 minus 3. We're just redoing the problem we did earlier, actually. So this is going to get us -13 divided by 6 times 6 times -1. 6's cancel, -1's are going to cancel, and that gets us 13, as we want. Okay, so that's our final answer. Okay, so for these kinds of write the equation problems, just start building the polynomial as best as you can, and then make sure you've taken into account all of the conditions that are there. That the degree is the right degree, it has the correct zeros. If there's some other point, then that point needs to be on that polynomial. Okay, hopefully that was helpful, and good luck studying, and take the practice quiz, and send me messages on Remind if you have any more questions or would like me to answer one of the questions from the homework from the week. So good luck, and I'll see you guys tomorrow.